Stars and their life cycle introduction. Asterisk. Since the dawn of human history, we have looked up at the night sky in wonder. Stars, those tiny sparkling points of light, have inspired myths, guided travelers, and fueled scientific discovery. But what are stars really? Are they eternal fires in the heavens, or do they live and die like everything else in the universe? In truth, stars are cosmic engines, massive spheres of glowing gas powered by nuclear fusion. They are born in giant clouds of dust and gas, shine for millions, or even billions of years, and eventually meet dramatic ends that reshape the cosmos. Some stars end quietly, while others explode in spectacular supernovas, creating black holes, neutron stars, and the very elements that make life possible. In this journey, we will explore the life cycle of stars from their mysterious birth in nebulae, to their long years of stability, and finally, to their extraordinary deaths. By the end, you will see how stars are not just distant lights in the sky, but the very building blocks of our universe, and even of ourselves. Asterisk. The birth of stars, nebulae, and protostars. Asterisk. Every star's journey begins in a mysterious and beautiful place, a nebula. These are vast clouds of gas and dust, sometimes stretching for hundreds of light years across space. To the human eye, they look like colorful, glowing clouds scattered across the night sky. The Orion Nebula, for example, is a famous stellar nursery located about 1,300 light-years away from us. Inside these nebulae, gravity starts to take control. Tiny particles of hydrogen and dust slowly gather, clumping together over thousands, even millions of years. As more and more material falls inward, the pressure and temperature rise. This marks the beginning of a new star. At this stage, we don't yet have a star, but a protostar, a young, forming object that is heating up but has not yet started nuclear fusion. Imagine a cosmic baby, still developing before it takes its first breath. The protostar glows faintly from the heat of all the gas collapsing inward. Eventually, the pressure at the center becomes so intense that hydrogen atoms begin to fuse together into helium. And when this happens, something incredible is born, the nuclear fire of a true star. From this moment, the star will shine steadily, fighting against gravity with the power of fusion in its core. This process, the transformation from a cold cloud of gas into a shining star, is one of the universe's most spectacular events, and it reminds us that even in the dark, silent void of space, new beginnings are always taking shape. Asterisk. Main sequence stars. The long life of a star. Asterisk. Once a star is born, it enters the longest and most important phase of its existence, the main sequence. This stage can last millions, or even billions of years, depending on the star's size. At the heart of the star, a powerful process called nuclear fusion takes place. Hydrogen atoms smash together under immense heat and pressure to form helium. This reaction releases a staggering amount of energy in the form of light and heat, the very energy that reaches us here on Earth from our sun. What makes this stage so fascinating is the delicate balance the star maintains. Gravity tries to pull the star inward, crushing it. At the same time, the energy from nuclear fusion pushes outward. The two forces balance perfectly, allowing the star to shine steadily for most of its life. Our sun is a perfect example of a main sequence star. At about 4.6 billion years old, it is halfway through its stable life. It still has another 5 billion years to go before it begins to change. But not all stars are alike. Smaller stars, known as red dwarfs, burn their fuel slowly, allowing them to live for trillions of years, far longer than the current age of the universe. On the other hand, giant blue stars burn through their hydrogen at a furious rate, living only a few million years before moving on to their next phase. So, whether a star lives a calm and quiet life like our sun, or a short but brilliant one like the massive blue giants, the main sequence is where stars spend the vast majority of their time. This stage is their prime, the period when they shine the brightest, nurture planets, and light up galaxies. Every time we look up at the night sky, nearly every star we see twinkling above is in this remarkable main sequence stage, steady, balanced, and full of life-giving energy. Red giants and supergiants, the aging of stars. As stars grow older, they eventually run out of their main fuel, hydrogen. When the hydrogen in the core is nearly gone, the delicate balance that kept the star stable begins to break. Gravity once again starts pulling inward, and the star's core shrinks and heats up. At the same time, the outer layers of the star expand enormously. The once stable star swells up into a red giant if it's a small or medium star, or into a supergiant if it is massive. Imagine this transformation. Our sun, which now fits more than 1,000,000 Earths inside it, will one day swell so large that it will engulf Mercury, Venus, and possibly even Earth. It will glow with a reddish hue, cooler on the surface but far more gigantic in size. Inside the core, fusion doesn't stop, it changes. Instead of just fusing hydrogen, the star begins to fuse helium into heavier elements, like carbon and oxygen. In the most massive stars, the process continues, creating elements all the way up to iron. This is how the building blocks of planets, and even life itself, are created. Red giants and supergiants are some of the most spectacular sights in the universe. Betelgeuse, in the constellation Orion, is a famous red supergiant, so large that if it replaced our sun, it would stretch all the way past Jupiter's orbit. But this swollen, brilliant stage doesn't last forever. It is a sign that the star is reaching the end of its life. For smaller stars, this leads to a gentle fading. For massive stars, it is the calm before the storm, a violent and explosive finale that will reshape the cosmos. In this phase, stars remind us of something deeply human. They shine brightly in their youth, grow into giants in their maturity, and eventually face the final stages of their lives. Their endings, as we will see next, are as fascinating as their beginnings. The death of low-mass stars, white dwarfs, and black dwarfs. When a star like our sun reaches the end of its red giant phase, it no longer has the power to keep its outer layers bound by gravity. Slowly, those outer shells of glowing gas drift away into space, creating a stunning display known as a planetary nebula. These nebulae are some of the most breathtaking objects in the universe. Colorful, glowing rings and clouds that shine for thousands of years before fading into the darkness. They are not planets at all, but the remains of a dying star's outer skin. At the center of this nebula lies what's left of the star, a small, incredibly dense core, known as a white dwarf. Imagine something the size of Earth, but with the mass of our sun compressed inside it. A teaspoon of white dwarf material would weigh several tons. White dwarfs no longer produce energy through fusion. Instead, they glow faintly with the leftover heat of their past life. Over billions of years, they slowly cool down, becoming darker and dimmer. Eventually, after an unimaginable span of time, the white dwarf may cool so much that it becomes a black dwarf, a cold, dead remnant of a once shining star. However, the universe is still too young for any black dwarfs to exist today, since even the oldest white dwarfs haven't cooled completely. This quiet, gentle death is the fate that awaits our sun. Unlike massive stars that explode violently, smaller stars end with elegance, leaving behind beautiful planetary nebulae and slowly fading into cosmic silence. It's a humbling reminder. Even stars as mighty as the sun eventually fade away. Yet, in their final act, they seed the galaxy with the elements needed for new stars, new planets, and perhaps even new life. The death of massive stars, supernova, while small stars like our sun fade away quietly. Massive stars end their lives with a bang, a truly cosmic explosion known as a supernova. For millions of years, A massive star burns through its fuel quickly, fusing hydrogen into helium, then helium into heavier elements like carbon, oxygen, and even iron. But when iron builds up in the core, fusion can no longer produce energy. The delicate balance of forces collapses in an instant. The core of the star caves in under its own gravity, while the outer layers are violently blasted outward into space. In just a fraction of a second, the star releases more energy than our sun will produce in its entire 10 billion year lifetime. This titanic explosion is called a supernova, and it is one of the most powerful events in the universe. For a brief moment, a single supernova can outshine an entire galaxy of billions of stars. Supernovae are not just spectacular. They are essential to the story of the cosmos. The explosion blasts heavy elements, gold, silver, iron, even uranium, into space. These elements mix with gas and dust, forming new stars, new planets, and eventually, living beings like us, in a very real sense. Every atom of calcium in your bones and every bit of iron in your blood was forged inside a long-dead star and spread across the galaxy by a supernova. Astronomers have witnessed these explosions across history. The famous supernova 1987A lit up the skies of the southern hemisphere and gave scientists a rare glimpse into this powerful process. Historical records show even earlier events, like the supernova observed by Chinese astronomers in 1054, which created the Crab Nebula we still see today. But the story doesn't end with the explosion. What remains after a supernova depends on the star's mass. Some leave behind neutron stars, incredibly dense objects, where matter is packed so tightly that a teaspoon would weigh as much as a mountain. Others collapse even further, forming black holes, regions of space where gravity is so strong that not even light can escape. Supernova are both endings and beginnings. They mark the violent death of a star, but also the rebirth of elements that make life and new worlds possible. In a sense, we owe our very existence to these cosmic fireworks. Neutron stars and pulsars, the cosmic lighthouses. When a massive star explodes as a supernova, its core collapses under the crushing force of gravity. If the star isn't massive enough to become a black hole, the core transforms into one of the strangest objects in the universe, a neutron star. A neutron star is unbelievably dense. Imagine squeezing the mass of our sun into a sphere only about 20 kilometers across, roughly the size of a city. In this tiny object, matter is packed so tightly that protons and electrons fuse together to form neutrons. A single teaspoon of neutron star material would weigh billions of tons. But neutron stars are not just heavy, they are also extreme in other ways. They spin incredibly fast, sometimes hundreds of times per second. Some neutron stars have powerful magnetic fields, which focus their energy into beams of radiation that shoot out into space. When these beams sweep across Earth, we see them as regular pulses of light, or radio waves. That's why these special neutron stars are called pulsars, cosmic lighthouses flashing rhythmically across the galaxy. The first pulsar was discovered in 1967 by Jocelyn Bell Burnell, who noticed a strange, repeating signal from space. At first, scientists even wondered if it might be a message from aliens. But soon, it became clear that these signals came from rapidly spinning neutron stars. Pulsars are so precise in their timing that scientists use them like cosmic clocks. Some are more accurate than the atomic clocks we use on Earth. They help astronomers study gravity, test Einstein's theories, and even map our galaxy. Neutron stars and pulsars are reminders of the incredible extremes in the universe, where the collapse of a dying star creates one of nature's most compact and powerful objects. They are the silent survivors of cosmic violence, sending out signals across space for millions of years. Black holes, the ultimate fate of massive stars. When the most massive stars in the universe reach the end of their lives, Even a neutron star isn't dense enough to contain their collapsed cores. Instead, they transform into something far stranger, a black hole. A black hole is a region of space where gravity is so intense that nothing, not even light, can escape. Once matter crosses the invisible boundary known as the event horizon, it is gone forever, trapped inside. To an outside observer, it simply disappears. Black holes come in different sizes. Some are only a few kilometers wide, formed from the collapse of a single massive star. Others, called supermassive black holes, contain millions or even billions of times the mass of our Sun. These giants sit at the centers of galaxies, including our own Milky Way, where a supermassive black hole, named Sagittarius A*, resides. What makes black holes fascinating is the strange physics that surrounds them. As matter falls in, it spirals around the black hole in a glowing disk called an accretion disk, heating up to extreme temperatures and releasing powerful X-rays. Some black holes even shoot out enormous jets of energy that stretch for thousands of light years. Einstein's theory of relativity predicted the existence of black holes long before they were ever observed. But today, we have direct evidence. In 2019, the Event Horizon Telescope released the first ever image of a black hole's shadow, located in the galaxy M87, a glowing ring of light around a dark center. Despite these discoveries, black holes remain one of the greatest mysteries of the universe. What happens to matter once it crosses the event horizon? Does it collapse into a single point of infinite density, a singularity? Or does it connect to other regions of space and time, as some theories suggest? Black holes remind us that the universe is full of wonders we are only beginning to understand. They are both destroyers and creators, swallowing stars, shaping galaxies, and perhaps even playing a role in the birth of new universes. In the grand story of stars, black holes represent the most extreme and mysterious ending of all, a place where time and space themselves seem to break down. We are made of stars as we've seen. The life of a star is an epic journey, from its quiet birth inside a nebula, to its long years as a shining main sequence star, to its final transformation as a red giant, white dwarf, neutron star, or even a black hole. But perhaps the most profound part of this story is what stars leave behind. In their fiery cores, stars create the elements that make up everything we know: carbon for our bodies, oxygen for our lungs, calcium for our bones, and iron for our blood. When massive stars explode in supernova, they scatter these elements across the galaxy, seeding new generations of stars, planets, and eventually, life. The atoms inside you, the ones that allow you to think, to breathe, to dream, were forged in the heart of stars that lived and died billions of years ago. As Carl Sagan famously said, "We are made of star stuff." Every time you look up at the night sky, remember, those twinkling lights are not just distant suns. They are storytellers of the cosmos, each one at a different stage, in a timeless cycle of birth, life, and death. And without them, there would be no galaxies, no Earth, no us. The life cycle of stars is not just an astronomical process. It is a reminder that we are deeply connected to the universe. From the smallest atom in our bodies to the brightest galaxy in the sky, it is all part of the same cosmic dance. So the next time you see the stars, know this: you are not simply looking at the universe. You are looking at your own origins. And in every heartbeat, every breath, you carry the legacy of the stars.